This section is on prime factorization, and I'll start off by doing just a prime factor of just a good old straight old number here. So let's take 140. And if the goal is to factor this to primes, remember that a prime is a number that is factored down to those factors which are divisible by itself in 1. So when you see a factor or a number here that we're going to factor out here, look at the end number and see if it's even. If it's even, you know that you can divide it by 2. So here is how I often do this. I go, okay, the factor of 140 is 2 times 70. And 70 can also be factored to 2 times 35. That can be factored to 5 times 7. So our prime factors of this are a function of 2's, 5's, and 7's. We take the 2's to the maximum that they are. This is 2 to the second times 5 to the first times 7 to the first. So this is 5 times 7 is 35. If you multiply 35 times 4, which is 2 squared, you will get 140. Okay, so that's factoring prime here. We're going to go up here and use that same technique, and with two different numbers, ask ourselves this: what is the GCF, the greatest common factor between these two, and the LCM, the least common multiple between these two? To find these two, we take each of these numbers and factor them. So 49 is relatively easy. It is 7 times 7. So that's 49. So we have two prime factors there. 35 is relatively easy. That is 5 times 7. Now, of course, this is 7 times 7 times x to the third, and this is 5 times 7 times x to the second times y. So here are the prime factors here as we've done this. Now, to find the greatest common factor between these two numbers, these two polynomials, we take each common factor, which means it has to be common to both, to the least power. So is 5 common to both? No, it is not. So we don't use that. Is 7 common to both? Yes, it is, but over here it's 7 to the second. Over here it's 7 to the 1. So we use the least power of each common factor, so that we have 7 to the first. Now let's look at, in order, is x a common factor? Yes, it is. What is the least power? It is 2. Okay. And we look at y. Is y common to both? It is not. So the greatest common factor between these two polynomials is 7x squared. Now, switching gears here a little bit, look over to least common multiple. In other words, if we took these two polynomials, what is the least common multiple? In other words, it's going to be some number bigger. What is the smallest of those numbers that these two are both a multiple of? How do we find that out rather than guess and check? Well, we've already factored them here, and we're going to use this prime factorization and say the greatest power or exponent of each prime factor. So let's go through this. Is 5 a prime factor? Yes, it is. And to what greatest power? It is to the 1. Times, is 7? Yes, it is. What is the greatest exponent or power? 2. Is x? Yes, it is. Greatest power to the third is y. Yes, greatest power is to the 1. So if we multiply that out, we get 245 x to the third y, and that is the LCM of that expression. And going back over here, this is the greatest common factor of this expression, the greatest common factor. Now again, you have homework, written exercises, page 181, 182. Yes, it's listed on EDU, but my recommendation is that you do as many as you possibly can in the A and B problems to make sure that you're familiar with this and can do it easily. I guarantee you see this material on SATs.